Hello everyone, this is Shravya. I'm currently pursuing my BE second year in Sri Venkateswara College of Engineering, Bangalore. In this video, I'm going to discuss about the subject DBMS, that is database management and system. And in this video, the topic is ER diagram and constraints and cardinality ratio. In that, let us know some introduction about the ER diagrams and cardinality ratios. In that, constraints, ER diagrams are graphically representations of a database structures showing entities, attributes, and relationships. And cardinality ratio constraints in ER diagrams define the maximum number of instances of one entity that can be associated with another entity. And this representing cardinality ratios accurately is crucial for database design and ensuring data integrity. And we have the entities in ER diagrams. Entities in ER diagrams represents real-world objects or concepts such as customers, products, and orders. Each entity has attributes that describes its characteristics and properties, and relationships between entities depict how they are connected and interact within the database. In this, we have the relationships in ER diagrams. That relationships in ER diagrams defines associations between entities and can have cardinality ratios. And we have common relationships types including one-to-one, one-to-many, and many-to-many. In these cardinality ratios determine the number of instances of one entity that can be linked to another entity. We have the symbols and representations of these ER diagrams. First one is rectangle that represents the entity, and second one is ellipses that represents the attribute, and diamond shapes that represents the relationship, and lines that links attributes to entity sets or entity sets to relationship sets. We have the double ellipses that represents the multi-valued attributes, and we have primary key that represents key attributes, single valued attributes. When come to the cardinality ratio symbols in ER diagrams including 1 for one-to-one relationships and N for one-to-many relationships, indicating one entity can be associated with multiple instances of another entity. And last one is M, that is many-to-many relationships, where multiple instances of both entities can be linked. First, we have one-to-one relationships. In one-to-one relationship, in each instances of one entity is associated with exactly one instance of another entity. And it is represented by the cardinality ratio 1 on both sides of the relationship lines. In example, we have one student and one course here. And we can represent one-to-one relationship here, that is student enrolled in and courses. Here, one student can enroll in at most one course, and one course can be enrolled by at most one student. And next one is one-to-many relationships. In a one-to-many relationship, one entity can be associated with multiple instances of another entity. It represented by the cardinality ratio n on the many side and 1 on the one side. We have two examples here. One first example is a customer can replace multiple orders, but each order belongs to only one customer. The symbol used for one-to-many relationship is R. Cardinality ratio is equals to 1:n. And we have another example of this one-to-many relationship, that is student enrolled in and course. Here, one student can enroll in any number of courses. One course can be enrolled by at most one student. And third one is many-to-many relationship. In many-to-many relationship, multiple instances of both entities can be linked, and it is represented by the cardinality ratio M on both sides of the relationship lines. We have two examples here. Examples one is student can enroll in multiple courses and each course can have multiple students. Here we have the symbol what we used in many-to-many relationship, that is diamond shape R. An example here, one student can enroll in any number of courses. One course can be enrolled by number of students. And we have the handling constraints in DBMS. Cardinality ratio constraints help enforce rules about the relationships between entities in a database. This ensuring data integrity of consistency by defining and implementing these constraints. These constraints can be specified during the database design test to prevent data anomalies. And we have the importance of cardinality ratio constraints. These cardinality ratio constraints prevent inconsistencies and ensure accurate data representations, and it helps in designing efficient database structures, and it will help to optimize query performance, and it enforcing constraints also aids in maintaining data quality and integrity over time. And when we come to the conclusion of these concepts, ER diagrams and cardinality ratios constraints play a critical role in database design, and the proper representations of these relationships and constraints ensures data integrity and consistency. And regularly viewing and refining cardinality ratios is essential for maintaining an efficient and reliable database. Thank you.